YouTube, what's good? It's your boy Hold It Down Jay, and thank y'all for tuning in today. Today we're going to talk about some networking fundamentals and specifically the OSI layer model. So the OSI layer model stands for Open Systems Interconnection Model, and is composed of 7 different layers. Each layer contains a job function, and they work together in order to ensure that data can move specifically from one computer to another over a network. So, with that being said, OSI layer has 7 layers, and the 7 layers are the following: physical layer, data link, network, transport, session layer, presentation, and application. After this break, we're going to talk about each layer and how they contribute towards the OSI model. An easy way for me to remember the OSI model is please do not throw saucy pizza away. Now, when you read the CCNA, it's going to tell you please do not throw sausage pizza away. Unfortunately, I don't eat sausage because I'm plant-based. And pause, first of all. So, with that being said, after this break, I want y'all to listen to the theme song, like, share, subscribe, and then we're going to break down each model. Alright, so the first layer we're going to talk about is the physical layer. The physical layer is simply deals with physical devices that translates raw data bits over a communication channel. So some examples would be hubs, also known as a dummy switch, network interface cards, and also Ethernet cords. And the list goes on, but those are the pretty basic ones of the physical devices. So for those who don't know what a bit is short for binary digit. So a binary digit is simply information that's composed of a sequence of zeros and ones. So all of our data in simple terms is made up of 0 and 1s. So when I say bits over a communication channel, I'm referring to the sequence of the ones and zeros based off the information that you're actually transferring. Layer number 2, the data link layer. So the data link layer's purpose is to mainly transfer bits into frames. So the frame is a unit data transmission. It's a structured packet that contains the data being transmitted and control information necessary for its delivery. So a device that I like to use to help people understand the data link is switches. So switches and also MAC addresses. So just to be specific, as far as switches, I want you to think about a local area network. So think about being inside the office. We'll just use this example. So I have 4 fingers for 4 computers. So the job of a switch is to transfer data in between all 4. So you may wonder, why isn't a switch, even though it's a physical device, not a part of physical? Well, the answer is simple. That's where a hub comes into play. So a hub on the physical side gives data. It causes collision because it can't send data in between each individual device. So if I send data within one computer, it'll send it to all of them. But the benefit of a switch and data link allows you to, if I'm this computer and I want to send it to this computer, it can skip this port and go to this actual computer. So that's why it falls inside the data link. The hub can't do that. That's why they call it a dummy switch, because it literally doesn't have the ability to singly transfer data. That's why it would always send data to everybody on its network and cause a collision every time. So the next layer we're going to talk about is the network layer. The network layer deals with taking data from one device to another across multiple networks. So think about it in the way of a post office. How the post office has to find the best route to deliver your package and assign it properly. There's no different when it comes to network layer. And a device to help you remember that is the router. Network layer routes data packets between networks. It addresses and routes packets based off logical addresses and based off the address and the network that you're attending to. And another thing about the network layer is the IP address that you have to look for. So IP address is the foundation of the internet. It's responsible for addressing and routing packets across the networks. Some examples of IP addresses would be IPv4 and IPv6. The reason why they made IPv6 was because IPv4, but I don't want to get into too much detail, but it's made up of a sequence amount of numbers. And the problem is that they ran out of numbers to assign each person an IP address. So what they ended up doing was creating IPv6. So IPv6, even though IPv4 is still used, IPv6 was created because IPv4 ran out of different IP addresses to be assigned. And you may wonder why the router is considered to be on the network layer in comparison to the physical layer or the data link layer. Yes, router is a physical device, but the reason why the router is on the network device in comparison to the physical device is because the router deals with routing on the network. So that's why we simply assign it on the network layer because it deals with IP addresses. Switches deal with more so of the MAC addresses. The fourth layer we're going to talk about is the transport layer. So the transport layer's responsibility is to ensure that data is transported correctly and the data maintains its integrity and never altered. Think of it as a way as the post office or an Amazon driver ensuring that when he delivers your package to your door, that it's in its perfect condition and nothing is messed up. If you order a coffee mug, there should be no glass shattered anywhere. It should literally come exactly as the picture said on the website. Two examples that I can give for transport layer is TCP and UDP. So TCP stands for Transmission Control Protocol. It's literally a protocol that can be used to ensure that data integrity is done when translating your data. An example of TCP would be the TCP three-way handshake, and that involves a relationship between a client and a server talking to each other to ensure that a connection is 100% confirmed and everything is good to go. The thing about TCP that I like is that there is a 0% chance of packet loss because they do extracurricular steps to ensure that each packet is transferred correctly in the right chronological order. So the next one we're going to talk about is UDP, User Datagram Protocol. And what that involves is instead of TCP, how it does extra checks to ensure that no packets are lost. The thing about UDP is the one thing I want you to take away is that TCP is connected oriented. So UDP offers connection lists. So when I say that, one example I can give from UDP is if I'm having a Skype call with somebody or either watch a YouTube video. You ever watch a video and it buffers a little bit? That's one perfect example I can give simply because when a YouTube video or you're Skyping somebody and the video buffers, it's because packets have been dropped. Now, if you want to ensure that you have a successful connection and none of the packets can afford to be dropped, then use TCP. The thing is that UDP is much of a quicker process in comparison to TCP. But both has its purposes, and that's the main objective of transport. So another thing I want to talk about is SSL and TLS. So SSL stands for Secure Sockets Layer and TSL is Transport Layer Security. These protocols allow encryption between end-to-end communication across the network. The reason why this is important because it ensures confidentiality and integrity over communication over the internet. The sixth layer is the presentation layer. The presentation layer simply translates, encrypts, and compresses data. Some examples you may see, if you have a photo that's in RAW format that's too big, that presentation layer gives it the ability to take a photo and compress it down into a JPEG. So it translated it from raw data to actually JPEG file. A better example, you ever took a 4K photo off your iPhone and then you send it to somebody that has an Android, and once the Android person gets it, it's very grainy? That's because when it sent that photo over, that file over, it transferred it possibly from a raw file to a JPEG and it compressed it, and now it doesn't have as good quality as it did before. So the final layer is the application layer. So the application layer is simple. It provides network services to applications. Some examples you'll see is HTTP or Hypertext Transfer Protocol, port 80. So on the World Wide Web, it gives web servers the ability to exchange files like text, images, videos. Another example would be SSH or port 22. The reason why this is important is because it's a secure way for somebody to remotely access a workstation or computer or server that they're accessing securely. So one example would be I'm in my physical computer, but I need to access a server remotely. So one way I can do it is I can SSH using a service like Putty, so I can remotely connect to my actual server, comfort of my home if I want. Another example is secure mail transfer protocol. That gives servers the ability to exchange emails over the internet. So it's used to send email messages between servers over the internet. You got Outlook or Gmail trying to email somebody, so it's done by SMTP, otherwise known as port 25. One tip I would like to bring up in an interview or just talking in general, it's very common to use layer 7 rather than saying application layer because it sounds like you know more of what you're talking about and it makes you sound a lot more confident. All right, YouTube, so y'all learned about the 7 OSI layer model and I already gave y'all a whole spin. Remember, do not eat saucy pizza and everything will be okay. And if you need to watch this a couple times, feel free to. Do some hands-on labs and I'll talk about more and we'll go over some more fundamental concepts to help you understand. In cybersecurity, you need to know what networking is. If you don't, you're going to have a very hard time trying to understand in the long run. So thank you. I appreciate it. And please like, share, subscribe, comment, let me know what you like, tell me what you don't like, and I get back to you on the next episode.